Hello. Today I'm going to go over fusion in this lecture here, and we're just going to cover some basic ideas. So this is talking about how stars are born or created, and it's going to start with fusion. Stars are stable and live for billions of years because of two opposing forces. So we've got fusion and gravity. Fusion pushes out on the star and gravity pulls in on the star. So fusion, it's like explosion, right? Think of a nuclear bomb. That's pushing outwards constantly on the star. And then the reverse of that is just gravity pulling in. Early on though, there's no fusion. When nebula start to condense, they get hotter and hotter. So as the dust accumulates in the center, it gets hot because of friction. And it can get really, really hot the more mass that's in there that's forming this protostar. Protostars are large balls of gas and dust that form at the center of a new solar system. The protostar is hot, but does not have fusion. So it has to heat up, okay? Once the protostar heats up to 12 million degrees Kelvin, fusion begins and a star is born. So this is the first step here of fusion. I'll talk about that in just a sec. The first step involves a hydrogen nucleus, a proton joining with another hydrogen nucleus. So once it reaches 12 million degrees, there's enough energy forcing these in this case, it's either a hydrogen nucleus or just a single proton. That's the same thing, hydrogen nucleus or an individual proton, same thing. There's enough energy there to force them together. They smash together. And what you get out of this is you get a hydrogen with a neutron attached to it. Let's see. Let's go to the second step. Each step of the process produces energy. The second step combines the new hydrogen with a proton. So now we have our previous version from up here, and that is going to combine with another proton or a hydrogen nucleus, again, however you want to think about it. These two smash together, produce energy, and now you've got this protohelium atom. The final stage of the process produces a full helium atom, which we see here. That's this one. This is a kind of a small version of a helium atom. It has two protons, but only one neutron. So when these two protoheliums smashed together, you get this helium with both protons and both neutrons, our normal helium atom. This is called nucleosynthesis, or the creation of complex atoms. The only place fusion occurs is in the core of the sun. So if you look at the star, the only place that's hot enough is in the core, 15 million degrees Kelvin. Very quickly, it cools down out of the radiative zone, then the convective zone. It's all below 1 million. So it's not hot enough here for there to be any kind of fusion going on. Only takes place in the core of the sun. This is the only region hot enough to fuse protons and hydrogens. So fusion is what actually starts the star that we think of. It's not a star until fusion occurs. Okay, hope this helps. Thanks.